Okay, welcome back. This is Chapter 3. Chapter 3 is about searching and selections, page 59. So let's just start from the beginning. Doing searches in something is a fundamental algorithm that, a lot of applications need. I mean, consider a database or an Excel spreadsheet when you're hunting for something, or even if you're in a Microsoft Word and you do a search for the word kumquat, it's going to have to start at the beginning and go all the way to it finds the word kumquat. So searching is kind of sort of normal, right? Now, sometimes the data that you're searching is in like database records or a list, and those things are kind of stored differently. They're stored in basically there's no hole, so to speak. If I had a bunch of records like a database, you wouldn't have like record number 1, number 2, and then a gap, and then 3 and 4. They're all squashed together, which makes it very efficient when you're doing searches because you don't have to go all over the place to find the next row on the Excel spreadsheet or the next record in the database or the next sentence in a Microsoft Word document. So now we're going to be using an array for almost all of our examples for the searching and the sorting coming up in the next chapter or two. So arrays are kind of sort of like that. Arrays are inherently very efficient for this type of work because when you build an array, it allocates a chunk of memory and puts all of the data in that one spot. It's never set up so that the first half of the array is over here and the second half of the array is over here. No, when you build an array, it makes it a contiguous, how's that for a good term? Contiguous chunk of memory, and all the array fits in there. So when it comes time to say, give me the next one, the machine doesn't have to think, well, where the heck did they put that? The next one is always right there, and then right there, and then right there. So that's the reason why arrays are very efficient for these types of things. Now, they do have some downfalls because you can't really delete in the middle and have the whole being collapsed, or you can't really insert in the middle without stretching the thing out. But for the stuff we're talking about now, like sorting and searching, well, then they're pretty doggone efficient. Okay. Some terms. The key or the target. I usually use the word target, but hey, the key is the thing you're looking for. So if we're searching for words in a Word document, or in our case, numbers in an array of integers, well, then that thing we're looking for is the key/target. Now, if your list that you're looking for is unsorted, like the words in a Word document one more time, then you really don't have any choices whatsoever. There's no fancy technique for going in and trying to find something. If the data we're looking for is unsorted, you really have no choice but just start at the beginning and go through it. There's not much fancy stuff involved in that. Now, if it is sorted, well, then we can do something really, really cool, which will be coming up here, called a binary search tree. We talked about that in the last couple of lectures, but now we get to actually demonstrate the thing. Okay, so page 60, they start talking about the sequential search, the bare bones, basic, technique for start at the beginning and hunt for the number. All right, so you look for the entire list, hunting for the target. When you find the target, you stop. Now, I said that, it's kind of sort of like, you've probably heard this, like you're hunting for your car keys, and you say, well, it's always in the last place I look. And I'm thinking, really? What kind of idiot would continue looking after they found it? Of course it's in the last place you look. Well, that's what we're talking about here. I go through this list, and when I find it, I stop. Okay, I found it. There's no need for me to look any further. I'm done. And so you return the location of the thing. So typical sequential search routines return the location in the array. In other words, if I'm hunting for 42, it doesn't say, okay, I found it. I found 42. Like, well, thank you, but where is it? So it doesn't return the target. It returns the location of the target. Now, I call that the index because that's a term you use when you're talking about a location in an array. So target, and then the index inside that is the location where that thing exists. Okay. Now, You also have to have a special return if it's not found at all, okay? Not there. So here it returns the target, the index, and here it returns a 0. Now, there's pseudocode examples in the entire book. Assume that arrays start at 1 and therefore a 0 is an impossible answer. That is not the way we're going to be doing it, so we're going to mentally change that when we do an implementation of this. Okay? All right, so that's what we're getting ready to do now. I'm going to write a program while you guys are watching that does exactly this. Now, I'm going to follow this as much as practical in implementing this exactly the way they have it in a programming language. Okay, so do pay attention, because this is going to get kind of interesting in a minute, because after we get this thing up and running, then we're going to instrument it, and you need to know how to instrument an algorithm. Okay, so here we go. So I've got Visual Studio, and I'm going to do mine in C#. So I want Visual C, and I want a console app, and I'm going to call mine Chapter 3. How's that for a good name? And we'll wait for this guy to come up. Okay, so I'm going to start with, I'm going to ignore this part for just a second and build me that particular method, okay? So first of all, the method returns an integer, so that's my return type, okay? And then I'm going to say sequential search. I pass to it an array of integers. I'm going to call it list. And then the target, whatever we're searching for, and then the size, and I'm going to call it max. Okay, so that's the way this thing starts off. Let's go back and look at this. So sequential search, list, target, and in. Now, I don't actually use the letter in because I'm getting ready to use that in another context, so just bear with me. I just use a variable called max, okay? And so then I need a for loop, but not exactly like that. My for loop is going to be 0-based for loop, okay? So here we go. So we say for int I is equal to 0, I is less than max, and I plus plus. Now that'll get me every single element in the array, because an array of 100 goes from 0 to 99. So I don't want to go to max. I want to go up to the thing that's less than max. Cool? All right. And then I have an if statement that basically says, hey man, does it match? So here's their example. They say, does the target equal the list? Okay, that's what we're going to do. We're going to say, does the target equal the list sub I? And if that's true, I just want to return the value for I, which is the index. In other words, that's the location in this thing where this thing occurred. Now, if it does not exist in the list at all, well, then I need a special return, but I can't use 0 because 0 is valid in our case. So I'm going to change it to a return of -1. Okay, now I have now implemented this thing, and it's pretty doggone close. I mean, other than that's a 0 and that's a -1. So you have to mentally change the thinking behind an array that starts a 0-based array. Okay, so now I need some code that can check this thing out. Now, this is kind of a simple way of doing things, but just bear with me. What I'm going to do is I'm going to build an array, and I'm going to put random numbers in it. Then I'm going to start looking for something. Okay? So to start with, let's have a value up here, that a constant. And I'm going to say constant int n is equal to 100. And I put it, see where I put it? I put it at the class level, not inside main or not inside the sequential search thing. So it's has higher scope. This is called a field variable. Some people call that a global variable, although technically it's not. But it's a field variable, so n is going to be the number of elements in my array. Okay, so now I'm going to need to be able to build me an array. Cool. All right. So I say int list is equal to new int, and I'm going to say n, because that tells me how big this thing is. Okay. Why? Haha, gotta spell it right. Okay, cool. So now I have an array and it has 100 elements in it. Great. I'm also going to need a random number generator, and so in your language this may be slightly different, but in mine it's going to be new random, like that. So whatever language you're using, it'll be similar, right? Not going to be that complex. And I'm going to need a variable for the target, and I'm going to need a variable for the returning index. Okay, cool. So step one is going to be, I need to build this array and fill it with random numbers. Okay, so let's do that. So I should need a for loop, right? Nothing fancy here. So it's just for int, and it doesn't really matter. I'm going to say I again, to I less than n this time, and I plus plus. And I'm going to fill it with random numbers in the exact same range. In other words, between 1 and 100. Okay? If I change n to 1,000, it'll be between 1 and 1,000. Okay? So I'm going to write my statement as if I could go to line 11 and make a minor little change, and then everything happens. Okay, so here we go. I'm going to say list sub I is equal to r dot, and then there's, in my language, it's next. And then I give it the range I want. I want 1 to n plus 1. Almost all, I'm going to go ahead and say that. I don't know that for a fact, but almost all languages, the ending parameter is not included. In other words, if you want numbers between 1 and 100, you'd have to say, I want between 1 and 101 on the parameter list. I know, it's crazy, but that's just the way random numbers have been for a million years. Okay. Now, I want to spit this out to make sure it worked. So a typical thing you would do in a homework assignment is build an array and then display it. Okay, so I'm going to do yet another little for loop. I'm going to use what's called a for each loop, or if in the Java world it's called an enhanced for, but that's okay. And I'm going to say int I in list. Again, in other languages it's slightly different. And then I'm just going to spit this thing out. So in my world, it's a console write. And then I'm going to say I plus a space. Okay. And then when I got to the end of this thing, I really need to have it break a new line. So I'm going to do a console write line. Like that. Now I'm going to go ahead and run this. It's not going to do anything. All it's going to do is build the thing and then spit out the contents of the array. We haven't done any searching yet, but let's just make sure everything looks the way it's supposed to look. So I'm going to hit start. And, ooh, what happened? So one of the things I have to do in my world is I have to go in here and say console read line. Otherwise, I can't actually see the data. Data appears and then disappears. So let's run this one more time. Okay, so what I've got now is 100 integers between 1 and 100. And I've got them displayed on the screen kind of nicely. This is probably going to be a requirement. This is a pattern. What I'm demonstrating for you now is a pattern that you're going to be using for almost all assignments from now on, so it'd be a good idea to pay attention. But of course, we're coming up on the 15-minute mark, so we'll continue this in the next part.